Series. Definition. A series is the sum of the terms of a sequence. The sum, as n goes from 1 to infinity, of a sub n is a1 plus a2 plus a3 plus ... is an infinite series. To find the sum of an infinite series, consider the sequence of partial sums. So the nth partial sum for this infinite series, the nth partial sum is the sum of an n number of terms. And a series is convergent if the limit as n approaches infinity of the nth partial sum is equal to s, where s is a real number, and divergent otherwise. The limit s is called the sum of the series. So if the limit as n approaches infinity of s sub n is equal to s, where s is a real number, then s is equal to the sum of the series. So the limit of the nth partial sum is equal to the sum of the series. Determine if the series converges or diverges. If it converges, find the sum. The series from 1 to infinity of 1 over 2 to the n. If I consider the first partial sum, so s sub 1 is equal to 1/2. S2, or the second partial sum, is a1 plus a2. So 1/2 plus 1 over 4, which is 3 over 4. The third partial sum, s sub 3, is 1/2 plus 1 over 4 plus 1 over 8. So it's a1 plus a2 plus a3, which is equal to 7/8. The fourth partial sum is a1 plus a2 plus a3 plus a4, which is equal to 15/16. And if I look at these terms, so 1/2, 3 over 4, 7 over 8, and 15/16, I can generate the nth partial sum. So the nth partial sum, it's clear that the numerator is 2 to the nth power minus 1. And the denominators are 2 to the power, so 2 to the nth power. So once I calculate the nth partial sum, I want to take a limit as n approaches infinity of the nth partial sum, which is the limit as n approaches infinity of 2 to the n minus 1 divided by 2 to the n. If I evaluate this limit, the numerator is infinity, the denominator is also infinity, which is an indeterminate form. So I'm going to use L'Hopital's rule. So this is equal to the limit as n approaches infinity. The derivative of the numerator is 2 to the n times natural log of 2. The derivative of the denominator is 2 to the n natural log of 2. So this is equal to the limit as n approaches infinity of 1. The limit of a constant is the constant itself. So the limit of the nth partial sum is equal to 1, which implies that the series converges. And that the series, or the sum as n goes from 1 to infinity, of 1 over 2 to the n is exactly equal to 1. Telescoping series. A1 minus A2 plus A2 minus A3 plus A3 minus A4 plus A4 minus A5. So as you can see, some terms in the middle cancel out. The negative A2 plus A2, the negative A3 plus A3, the negative A4 plus A4. A telescoping series will converge if and only if A sub n approaches a finite limit. A telescoping series will converge if and only if A sub n approaches a finite limit. So determine if the following series is convergent or divergent. The sum as n goes from 2 to infinity of 1 over n squared minus 1. So if I write out a few terms, the first term is 1/3. The next term is 1/8. The next term is 1/15, and so on. I can't tell if it's telescoping yet, but I can factor the denominator. So this series can be rewritten as the sum from 2 to infinity of 1 over n plus 1 and minus 1. So now I'm going to figure out the two fractions this came from, and I'm going to use partial fraction decomposition. So a over n minus 1 plus b divided by n plus 1 is equal to 1 over n plus 1 and minus 1. So if I multiply both sides by the LCD, a times n plus 1 plus b times n minus 1 is equal to 1. If n is negative 1, then I get negative 2b is 1, so b is negative 1/2. If n is 1, Then I get 2a is equal to 1. So a is positive a half. So this series turns into the sum from 2 to infinity of a over n minus 1. So 1/2 over n minus 1 plus b over m plus 1 plus negative a half divided by n plus 1. Both of these have a 1/2 in common. So I can factor out the 1/2 times the sum from 2 to infinity of 1 over n minus 1 plus 1 over n plus 1. So now if I expand out these terms, an n number of terms, so the nth partial sum would equal, there's a 1/2. When n is 2, I have 1 over 1. There's a typo on the previous line. This plus a negative a half is right. This positive should be a negative. So if I erase this positive, the sign between those two fractions is a minus. Since all I did is factor out a 1/2 from both of those fractions. So when n is 2, 1 over 1 minus 1 over 3. This is when n is equal to 2. When n is 3, 1/2 minus 1 over 4. This is when n is 3. When n is 4, plus 1/3 minus 1/5. This is when n is 4. If I continue this pattern, the n minus first term is 1 over n minus 2 minus 1 over n. This is the n minus first term. Or a sub n minus 1. And then the nth term, so plus 1 over n minus 1 minus 1 over n plus 1. So this term is a sub n. The term before it is a sub n minus 1. So there's a 1/2 left. What's also left is this 1 over 1. The negative 1/3 will cancel with this positive 1/3. The 1/2 is also left. If I expand more of these out, the negative 1 over 4 will cancel with the positive 1 over 4 when n is equal to 5. The negative 1/5 will cancel with the positive 1/5. The negative 1/6 will cancel with the positive 1/6. this 1 over n minus 2 will cancel with 2 before that term. And then I'm also left with a negative 1 over n and a negative 1 over n plus 1. This 1 over n minus 1 will cancel with the 1, 2 before this one. So the nth partial sum is equal to 1/2 times 1 plus 1/2 minus 1 over n minus 1 over n plus 1. Then if I take a limit of the nth partial sum, so limit as n approaches infinity of s sub n is equal to the limit as n approaches infinity of 1/2 times 1 plus 1/2 minus 1 over n minus 1 over n plus 1. So this limit is equal to 1/2 times 1 plus 1/2, which is equal to 3 over 4. Therefore, the series from 2 to infinity of 1 over n squared minus 1 is convergent and that series is exactly equal to 3 over 4, or the sum of that telescoping series is exactly equal to 3 over 4. Determine if this series is convergent or divergent. The sum from 1 to infinity of 1 over n plus 2 minus 1 over n plus 3. So the nth partial sum, s sub n, when n is 1, 1/3 minus 1 over 4. When n is 2, 1 over 4 minus 1 over 5. When n is 3, 1/5 minus 1/6. When n is 4, 1/6 minus 1/7. If I continue that pattern, the nth term is 1 over n plus 2 minus 1 over n plus 3. So there's a 1/3 that does not cancel. The negative 1/4 plus 1/4 will cancel. The negative 1/5 plus 1/5 will cancel. The negative 1/6 plus 1/6 will cancel. This negative 1/7 will cancel with the next term. And the 1 over n plus 2 will cancel with one of them before. And the only one that's left would be the minus 1 over n plus 3. So the nth partial sum is equal to 1/3 minus 1 over n plus 3. So the limit as n approaches infinity of the nth partial sum is equal to the limit as n approaches infinity of 1/3 minus 1 over n plus 3, which is equal to 1/3. So therefore, the series is convergent and the sum of the series, so the sum as n goes from 1 to infinity of 1 over n plus 2 minus 1 over n plus 3 is equal to 1/3. So for telescoping series, factor the denominator, use partial fraction decomposition to determine whether or not you have some sort of telescoping factors in there. Geometric series. The sum as n goes from 1 to infinity of a1 r to the n minus 1. When n is 1, the first term is a1. When n is 2, the next term is a1r. The next term is a1 r squared plus a1 r cubed, and so on. Or it could also be written where n starts at 0 to infinity of a r to the n, or a1 r to the n. This is a geometric series. Since to go from one term to the next term, I have to multiply by r. To go from this term to this term, I multiply by r. So there's a common ratio, which is r. Theorem. convergence of a geometric series. The infinite sum, or S sub infinity, is equal to the sum as n goes from 1 to infinity of a1 r to the n minus 1 is equal to a1 divided by 1 minus r. If 0 is less than the absolute value of r, which is less than 1, and diverges if the absolute value of r is greater than or equal to 1. So determine convergence or divergence. If the series is convergent, find the sum. Four plus 2 plus 1 plus a half plus 1 over 4 plus 1 over 8 plus that pattern continues. So a1 is 4, and there's a common ratio of 1/2. So I can rewrite this as the sum as n goes from 1 to infinity of 4 times 1/2 to the n minus first power. Since this is a geometric series with r equal 1/2, which is strictly less than 1, this implies that the series converges. Since it's a geometric series with r less than 1. And I'll indicate that it's a geometric series. So when you test these series, indicate the type of series and what test you're using to determine convergence or divergence. So the sum as n goes from 1 to infinity of 4 times 1/2 to the n minus 1 is exactly equal to 4 over 1 minus r. a1 over 1 minus r. So 1 minus a half, which is equal to 4 divided by 1/2, or 8. So this series is exactly equal to 8. And this series converges, and it converges to 8. So the sum of the series is equal to 8. Determine convergence or divergence for this series. 81 minus 27 plus 9 minus 3 plus 1 minus 1/3 plus 1/9 minus 1/27 plus ... So the first term is 81. This series is geometric with r being negative 1/3. So I can rewrite this as the sum as n goes from 1 to infinity of the first term 81 negative 1/3 to the n minus first power. So geometric series with absolute value of r equals the absolute value of negative 1/3, which is less than 1. Therefore, it's convergent. And this series is equal to, or the sum of the series is equal to A1, which is 81, divided by 1 minus r. So 1 minus negative 1/3. So 81 divided by 4/3, or 81 times 3 over 4, which is 243 divided by 4. One plus 5 plus 25 plus 125 plus ... So A1 is 1. The common ratio is 5. So this is also a geometric series. And I can rewrite it as the sum as n goes from 1 to infinity of 1 times 5 to the n minus 1. It's a geometric series with r is equal to 5, and since it's bigger than or equal to 1, the series diverges. Or the series is divergent. Theorem. If the series from 1 to infinity of a sub n converges, then the limit as n approaches infinity of the nth term a sub n is equal to 0. But the converse is not true. So if the limit as n approaches infinity of a sub n is equal to 0, then the series as n goes from 1 to infinity of a sub n may converge or diverge. So in other words, it's inconclusive. However, there is an nth term test for divergence. It's the easiest test to check for divergence. If the limit as n approaches infinity of a sub n is not equal to 0, then the series from 1 to infinity of a sub n diverges. This theorem does not show convergence. So if the limit of the nth term is non-zero, then the series diverges. So for the following, determine convergence or divergence. The sum from 1 to infinity of 3n cubed divided by n cubed minus 20. Okay, if I take a limit of a sub n, so the limit as n approaches infinity of 3n cubed divided by n cubed minus 20. If I take a limit, I have infinity divided by infinity, which is an indeterminate form. You can use L'Hopital's rule. You can use a Calc 1 technique where you divide numerator and denominator by the highest degree term in the denominator. So if I divide each term by n cubed, so limit as n approaches infinity, 3n cubed divided by n cubed is 3. N cubed over n cubed is 1 minus 20 divided by n cubed. If I take a limit, 3 over 1 minus 0, or 3. Since the limit of a sub n is non-zero, this series, so therefore the series from 1 to infinity of 3n cubed divided by n cubed minus 20 is divergent by the nth term test for divergence. And you have to write the condition of the test and the test that you used. By nth term test for divergence. So you have to show your knowledge of each test to satisfy the conditions. Determine whether or not the series as n goes from 1 to infinity of 3 to the n divided by n cubed is convergent or divergent. So if I take a limit to infinity, I do get infinity over infinity. There are function growth rates. Natural log of x grows at a lower rate than polynomials, which are lower than exponentials, which are lower than factorials, which are less than x to the x power. So the limit as n approaches infinity of the nth term, or 3 to the n, divided by n cubed. Infinity divided by infinity, which is indeterminate, so I'm going to use L'Hopital's rule. Limit as n approaches infinity. Derivative of the numerator is 3 to the n times natural log of 3 divided by 3n squared. This limit is still infinity over infinity, which is indeterminate. So I'm going to use L'Hopital's rule again. Limit as n approaches infinity of 3 to the n, natural log of 3 quantity squared, divided by 6n. If I take a limit, infinity over infinity, which is still indeterminate, so I'll do L'Hopital's rule one more time. This is equal to the limit as n approaches infinity of 3 to the n times the natural log of 3 cubed divided by 6. So this limit is equal to infinity, which is non-zero. So therefore, the series from 1 to infinity of 3 to the n divided by n cubed diverges by the nth term test for divergence. Theorem. If the series a sub n and b sub n are convergent, then 1, the series C times A sub n is equal to C times the series A sub n is also convergent. And 2, the series A sub n plus or minus B sub n is equal to A sub n plus or minus B sub n is also convergent. So telescoping, the limit of the nth partial sum as n approaches infinity is a number. Then the series converges, and it converges to that value. Geometric series, if 0 is less than, absolute value of r is less than 1, then the infinite sum is a1 divided by 1 minus r. And then test for divergence. If the limit as n approaches infinity of a sub n is non-zero, then the series is divergent.